Okay, guys, so I'm just going to go through and do the odd problems from the homework for tonight. What we're going to start doing for the next two classes is we're going to learn a method called U substitution. You can kind of think about it as the backwards chain rule. But sometimes in order to use it, we need to rewrite the curve or the function that we have to make it just more. I'm going to look at number 4 real fast, even though I'm not going to do it. Written in this form, it's going to be really hard to integrate something that looks like this because we don't have a quotient rule. But sometimes when I divide this into my dividend, so if I take my divisor and divide it into this, the value that I get when it's rewritten can sometimes be easier to work with. And I think once I do number 1, you'll kind of see this. So the purpose of this is just to be able to rewrite what I've been given to make it a little more friendly for integrating. So let's start looking here. I'm going to divide this into this. So I'm going to have x plus 2, and I'm going to divide this into 12x to the 4th plus 22x cubed minus 11x squared minus 15x minus 9. And when I do long division, I'm going to take my leading term of my divisor and divide it into this leading term here. So x is going to go into this 12x cubed times. And then I'm going to take this and I'm going to multiply it by this. So that's going to give me 12x to the 4th power plus 24x to the 3rd power. And now I'm going to subtract this out. So here we go. So this minus this is going to give me 0. 22x cubed minus 24x cubed will give me a negative 2x cubed. And once I do that, I'm going to drop this next term here. So now I have a minus 11x squared. I'm going to repeat the process. I'm going to take my largest term and divide it into my largest term, or my leading term, which is going to give me negative 2x squared. Again, I'm going to multiply, I'm going to distribute this out again to over here. That's going to give me negative 2x cubed. Notice I'm always picking something so that this first term is going to subtract out. So that's going to give me minus 4x squared. Again, I'm going to subtract this out. That's going to give me 0. I'm going to have a negative 11x squared plus 4x squared. So I'll have a negative 7x squared. And I can drop this term. Again, I'm going to take my leading into my leading, so x into negative 7x squared will give me a negative 7x. I'll multiply that through, that'll give me a negative 7x squared minus 14x. When I subtract these, I'll get 0, and then I have a negative 15x plus 14x, so negative x. Drop my last term. Again, leading into leading, so x goes into negative x negative 1 times. When I multiply that out, I'm going to get a negative x minus 2. And when I subtract these, I'm going to end up with a remainder. So remember, I've got, these will become 0. I've got negative 9 plus 2, because I'm subtracting a negative. I'm left with a negative 7 left over. So this still needs to be divided by x plus 2, but now the degree of this is less than the degree of my leading term. That's my remainder. I'm going to actually just leave this as minus 7 over x plus 2. So this thing that I now have, my quotient, is mathematically equivalent to what I started with. So let me highlight this real fast. So here's my quotient. This is mathematically equivalent to this expression that I started with, but this is going to be a lot easier to integrate because this I have a rule for. I can use that the inverse power rule. This I can do this, I can do this, and this is actually going to be fairly easy to work with. So that's why we like rewriting in this form. Let's do another one. Notice now I'm going to divide by something that has 3 terms. So let's get this set up. I've got x squared minus 6x plus 3, and I'm dividing this into 5x to the 4th minus 26x cubed minus 5x squared minus 12x. I'm worried about this missing a term, so I've got x to the 2nd power, x to the 1st power, and then I have my constant. And this actually, I know it's missing the constant at the end, but we have to the 4th, to the 3rd, to the 2nd, to the 1st power. A lot of times, or typically, if you're missing one in the middle, let's say I have no x cubed term, when you write it out here, you're actually going to want to put in a placeholder, so like plus or minus like 0x cubed, just to make this process easier. But in this case, we don't have to worry about that. So again, I'll take my leading into my leading. That's going to give me 5x squared. We're going to multiply that out. It's going to give me 5x to the 4th minus 30x cubed plus 15x squared. One of the biggest mistakes I make when I do this is I know I'm supposed to be subtracting these, and I normally do that right for this first term here, but sometimes I forget as I go, so sometimes writing this out it's just helpful to not forget. So this minus this is 0. Negative 26x cubed plus 30x cubed is going to give me 4x cubed. Negative 5x squared minus 15x squared will give me a negative 20x squared. I'm going to drop this term. Repeat the process. X squared goes into 4x cubed 4x times. Multiply that through. I'm going to get 4x cubed minus 24x squared plus 12x. Time to subtract. This minus this is 0. Negative 20x squared plus 24x squared will be 4x squared. Negative 12x minus 12x will give me negative 24x, so be careful there. Now notice I don't have a constant term here, so I could write a plus 0 if I wanted, but I'm still going to do this process again because the degree here is the same as the degree here, and I can tell very easily that x squared goes into 4x squared 4 times. Typically you're going to keep going until you have a constant here. So multiply that out. It's going to give me 4x squared minus 24x plus 12. I'm going to subtract, and you'll notice fairly conveniently I'm actually going to lose 2 of these terms. This will subtract to 0, this will subtract to 0, so I'm really left with a minus 12. Because this degree is less as my constant term, we kind of stop here. This is my remainder, and I'm going to leave this as a minus 12 over x squared minus 6x plus 3. Again, this is something that's going to be easier to work with when we integrate. This thing that I'm highlighting here, my quotient, is still mathematically equivalent to what I started with. Normally something like this will look more like this, but this is going to be easier to work with. So that's long division. You guys are going to do number 2 and number 4 on your own. I'll post a key with the answers for you to check. Let's go down to completing the square. This is also just a tool that's helpful. We're actually going to solve this quadratic by completing the square, but just make sure you're paying attention to this process as we go. Normally when we solve an equation, we check for factoring first, and I can tell pretty quickly this isn't factorable because the only way I can multiply to 3 is 1 and 3, and those definitely aren't going to combine to add up to 6. So a lot of times we'll use the quadratic formula next, but this is another method that works really well. When we complete the square, we're going to take these 2 terms, and we're going to try to add a value that when we simplify, we'll turn it into like an x plus or minus a value squared. So I'm actually going to pause this really fast and write this. Our goal is to get something in the form that looks like this. You'll notice when I FOIL this out, so when I have x plus a times x plus a, I'll get an x squared. I'm going to get x times x plus a twice when I FOIL this out, and I'll get an a times a, which is a squared. So ideally, like this value doesn't currently match this. We'll talk about that in a second. So we're going to add some value to this to make this end up looking like this. In order to make it a little easier, I'm actually going to take this and move this to the other side. But to balance my equation, since I'm adding something to this side, I also need to add it to this side to balance the equation. Now remember, our goal is to make this kind of look like this. We need to figure out what this a value is. And if we start comparing this, you'll see I have an x squared. This is my 2ax term. Well, there's my x, so 6 has to be 2a. That means my a value in this case is 3. Well, this blank, in order to complete the square, needs to be a squared, and we just determined that a is going to be half of 6, which is 3. 3 squared is 9. So 9 is going to go here, 9 is going to go here to balance my equation. Well, this now is mathematically equivalent to this. This is the process of completing the square. We're turning this into something square. We had to add something to both sides to do that. So, so there's that. On this side, I have 6. Okay. So we've done the process of completing the square, but they're actually asking us to solve the quadratic. The nice thing about when it's in this form is we can actually solve for x fairly easily by taking the square root of both sides and then subtracting 3. So this is an alternative method to the quadratic formula. So if you ever forget it, but you feel more confident in completing the square, that's always an option. We essentially just move the constant term to the other side, determine what my a value is. It's always going to be half of the value here. So this was 6, so my a value is 3. We square that to get the value that goes in the blank. And then once we've completed the square, we just take the square root of both sides and add or subtract the value that's with that x. So I hope you guys found that helpful. You're going to complete the square for number 6. We can talk more about this next time a little bit, but these are some tools that you're going to want to feel comfortable with as we go into this next portion of integrating. So I hope you guys have a good rest of your day, and I'll see you soon.